Write the area of an equilateral triangle as a function of side length S. So,
Please pass it down.
the area of a triangle is what?
Oh, thank you.
What's the formula? Okay, base times height divided by 2. Come on, people. Okay. So, they do tell us, listen up, that it is an equilateral triangle, meaning all the sides are the same length. So we know base is what? S. Okay, so because we do want to write it in terms of side, in terms of S. Now we just got to figure out the height. Now this is an equilateral triangle. What do we know about the length of just this part right here? Half of S, right? S over 2. Everyone okay with that? This right here is the height. This forms what type of angle?
Right angle.
Okay, everyone okay with that? So what we really have is a right triangle.
1/2.
So we use Pythagorean theorem to solve for h in terms of s. So we have s squared, no, s over 2 squared plus h squared is equal to s squared. Any questions there? Right. A squared plus b squared equals c squared. So we have s squared over 4 plus h squared is equal to s squared. We want to get h by itself. So we have s squared over 4 minus s squared is equal to negative h squared. So let's just change the signs of everything. Square root both sides. Let's get a common denominator. We have the square roots of negative s squared plus 4s squared over 4 is equal to h.
Square root over.
It's not a mistake, it's just a bad drawing. Any questions there? Okay, now we can square roots the bottom. And yeah, let's just leave it like that. I'm going to switch these two just so that it says 4s squared minus s squared over 2 is equal to h. Alright, any questions there? So now do we have everything in terms of s? Yeah, so now we plug it back into this formula. So the area is base, which is what?
S.
S times the height, which is this whole thing.
Wouldn't that be square root of 3s squared?
Yeah, s. So 3s squared, good.
We can take out
Over 2 over 2. So this is s square root of 3s squared, which is s, right? We can simplify that again. Take out an s from there. That makes that a square over 4. So this is your area. And then you can take the derivative of this. So this is part A. That's the answer for A. B is asking for find the instantaneous rate of change of the area in terms of s. Alright. These are just numbers. So you do the power rule. You 2s square root of 3 over 4 is the derivative of that. You can simplify the 2 and 4 and that's your answer. Alright, anything else? Okay, and then for C, you plug in numbers. So I'm not going to plug in numbers for you guys. Just plug it in and calculate. But the answer is square root of 3 and 5 square root of 3. Alright, 5, 7, and 9. 5. Okay, we're going to skip 5 and 7. Let's look at 9. Because 9 is the more important one out of the 3. Because there is going to be something like this for sure on the AP test. The accompanying figure shows the velocity v equals f of t of a particle moving on a coordinate line. So it's just moving left and right. A, when does the particle move forward? Okay, so it gives you the graph. One, 2, 3, 4, 5, 6. Okay, so the graph looks like that. When does the particle move forward? So, in order for the particle to move forward, the velocity has to be what? Positive or negative? Or 0? Positive. The velocity has to be positive.
Yeah.
So, where's the velocity positive here?
0 to 1.
Okay, from 0 to 1, so this is where it's positive. So from 0 to 1 second. Let's see how they wrote the answer. See page 140. Okay, so they want it in with inequalities. Okay, so it's moving forward in between that interval. When else is it moving forward? 5 to 6? Or 5 to 7? Anything else? Is it moving forward here?
No.
But the slope is positive.
Oh.
No.
No.
So only when it's above the
Yeah,
x-axis?
only when it's positive. The slope may be positive here, but your velocity is still negative. Okay, so that has to do with the derivative graph. Right? That's what a lot of people get tripped up about. Yeah.
Why does it say less than or equal to? For like 5 and 7. Because the book answer gave 5.
Oh, just 5 and 7?
Yeah.
Not equal to? Okay.
I think it was less for the 0. And it was.
Did it include 0 or no?
Yeah.
Okay. Well, I guess, yeah, that makes sense, because that's where it stopped, because velocity is 0. Okay. Any other questions with A? Here, when does it speed up? When does it slow down? Okay, so that's forward. When is it backwards?
1 to 5.
Yeah, when it's negative, so 1 to 5. Questions there? When is it speeding up? Okay, so when is it speeding up?
When it goes straight.
1 to 2.
The slope is.
When it goes away from 0.
Yeah, so from 1 to 2. So you can't tell in this picture, but in the book it's really like this. So this is steeper than this in the book, in the picture. So it speeds up from 0 to 2. Right? Yeah.
Yes.
Wait, but it's going from to 0. Isn't that that's velocity, right?
Yes. So it should be.
It should be like this.
velocity, so he's going forward. Oh, you're right, So it's not 0 to 2. So when is it? When is it?
Should be like away from 0. So,
Away from 0, so
when it's like going away from 0.
so when?
5 to 6.
Yeah, 5 to 6.
Wait, does it matter which way it's going, or if it doesn't matter which way it's going, then there's
Yeah, I guess it doesn't matter.
There's a lot of places today.
Well, there isn't a lot of places. It's just this right here from 1 to 2.
Oh yeah, 1 and 2.
And then
5 and 6. 5 and 6 is
5 to 6. No, 5. Yeah, 5 to 6.
Whenever it gets.
So when it's going away from 0 is when it's speeding up. Because it's going towards 0. Here, 6 to 7 or whatever, it's going towards 0, so it's actually slowing down. The velocity is slowing down.
Wait, 5?
Wait,
Six.
but I thought
6 to 7.
1 to 2, it was slowing down because the velocity was going towards negative.
But it's going away from 0.
But it's going away from 0. So the velocity is negative, but it's going faster.
So even if it's going back in reverse, it's still going
Right.
back.
It's going away from 0.
Right, imagine a car driving in reverse, but it's speeding up in reverse. So 1 to 2?
Yeah.
How many driving points is that?
How many times? What?
How many
It's easy for them to decide.
I'd say 2. Because I think there's one up here and one down here. Okay. When is it slowing down? So it's slowing down when it's going towards 0. So 0 to 1 is when it's slowing down. I think that's 3 to 5, or whatever that interval is in the book. And then 6 to 7.
Wouldn't it be 6 to infinity?
No. Because at 7, the velocity is 0, so it stopped. So it's not slowing down anymore.
7 to infinity still.
Yep. Alright, any questions with part A? Okay, part B. When is the particle's acceleration positive?
What is above the x-axis?
Yeah?
What is going up?
When what is going up?
The line.
Okay, so,
When it is above.
like here?
Yep. When it's above the x.
When it's above the x? So here? Is the acceleration going positive here?
No.
No, it's slowing down.
It's positive.
It's slowing down. So the acceleration is the same thing as when it's speeding up, right? If you're speeding up, you're accelerating.
So it's from the bottom to its peak.
So 1 to 2 is when the acceleration is speeding up. Because imagine you're driving a car. You slow down here to 0 velocity. Here you're in reverse, so you're speeding up. So the acceleration, you're stepping on the gas. Here, you're slowing down, so you're letting go of the gas, so you're not accelerating anymore. Here, you're speeding up, so you're pressing on the gas, so you're accelerating. So again, it's when it's going away from 0.
So one. Okay. It is easier when you think about it as a car.
Yeah, instead of a particle.
1 and 2, 5 and 6.
Okay, when is it negative? When is the acceleration negative? Acceleration is negative when you've let go of the gas, but it's still moving.
No way. Slow down.
So when you're slowing down. So when it's going towards 0. So here, it's slowing down. Here, your acceleration is negative. Here's your acceleration 0, because you're not even moving anymore. When your acceleration is negative, that's when you're decelerating. So when you're slowing down. When does the particle move at its greatest speed? It's got to be here.
Why?
Because the slope is steeper here, so you're accelerating the most. And then, but this here, you're no longer accelerating. So that's your constant speed, but then you start slowing down again here.
Why wouldn't it be?
Okay, so in the book, it's down here somewhere. That's why. So this is, the velocity is a lot more negative here than this is positive here. So your acceleration is more. So just my drawing isn't on point. when does a particle stand still? For more than an instant. Where? At the end, right? Here on.
2 to 3.
For more than an instant, though. From 2 to 3 is still moving. It's just moving at a constant rate now. Velocity isn't changing.
So went from 0 to 7 to 9.
Huh?
From 7 to 9. Not that long.
Yeah.
Yeah, 7 to whatever is not moving anymore. So it's standing still. Alright, questions? Alright, if you didn't get it, you will eventually because we're going to continue constantly be doing problems like this.
Okay. Page number 5, please.
7.
So you put it on a graph.